This lesson describes a strategy for balancing combustion reactions. Recall that combustion reactions can easily be recognized when the molecules of oxygen appear as reactants, as indicated by the arrows. Sometimes the products can also identify a reaction as combustion. Typically, if you see water as a product and either carbon dioxide or carbon monoxide, you're generally looking at a combustion reaction. A good strategy to employ when balancing a combustion reaction is to balance the oxygen atoms last. You'll need to be careful because oxygen will be found in more than one product or reactant, and the sum of oxygen on each side will have to be determined before you can balance. For example, you can see on the product side of each of these three examples, oxygen appears in each of the products. Let us begin example A by balancing oxygen atoms last. We'll begin by balancing the carbon atoms. You can see on the reactant side there are 3 carbon atoms. However, on the product side, there's only 1 carbon atom. Therefore, a coefficient of 3 will be chosen. This creates 3 carbon atoms on the product side. Now that carbon is balanced, let us go ahead and balance our hydrogen. You can see on the reactant side there are 8 hydrogen atoms. However, on the product side, there only exists 2 hydrogen atoms. Therefore, the coefficient 4 will be chosen as the multiplier to create the 8 hydrogen atoms necessary. Now we will need to add the oxygen atom sum total from the product side so we can begin to balance oxygen. We can see from carbon dioxide 3 times the 2 oxygen that were already present creates 6 oxygen atoms, and from water 4 times the 1 oxygen atom that was already present creates 4 oxygen atoms. Therefore, 6 plus 4 gives us the sum total of oxygen on the product side, or 10 oxygen atoms. To create 10 oxygen atoms on the reactant side, a coefficient of 5 will be chosen as our multiplier. We now have arrived at a balanced equation for this particular example. In this example, there is a ratio of 1 to 5 on the reactant side and 3 to 4 on the product side. Let us now look at example B. Again, employ the strategy. Balance the oxygen atoms last. Let us begin by balancing our carbon atoms. You can see on the reactant side that there are 4 oxygen atoms. However, on the product side, there is only 1. Therefore, a coefficient of 4 will be chosen for the product side in front of carbon dioxide. Let us look at our hydrogen atoms now. On the reactant side, there is a total of 10. However, there exist only 2 on the product side. Therefore, a coefficient multiplier of 5 will be chosen to create the 10 hydrogen atoms needed on the product side. Now we must find the sum total of oxygen on the product side. 4 times the 2 oxygen that were already present for carbon dioxide creates a total of 8 oxygen atoms. For water, 5 times the 1 oxygen atom that was present creates a total of 5 oxygen atoms. Therefore, a total of 13 oxygen atoms are needed to balance this equation. You can see there is no whole number we'll be able to place in front of oxygen on the reactant side to create 13. However, we can employ a value that has a half value assigned to it. So we're looking for the value that we could multiply by 2 that would create 13. 6.5 would create 13, so we will temporarily place the 6.5 in front of oxygen. Although this balances the equation, this does not provide the simplest whole number ratio. A simple strategy to eliminate the half amount would be to multiply each of the coefficients by 2. In doing so, the 1 or assumed 1 in front of C4H10 becomes 2. The 6.5 in front of O2 becomes 13. The 4 in front of CO2 will become 8. And the 5 in front of H2O will become 10. This balances the equation with a reactant ratio of 2 to 13 and a product ratio of 8 to 10. Let us now look at example C. Once again, because it's a combustion reaction, we will balance our oxygen atoms last. Therefore, on the reactant side, we see that there are 2 carbon atoms. To create 2 carbon atoms on the product side, we will choose the coefficient 2 in front of CO. In looking at the hydrogen, we can see the hydrogen is balanced on each side of the reaction, with 2 hydrogen atoms found on the reactant and product sides. Let us now look at oxygen. We can see that the oxygen appears in 2 places again on the product side. Therefore, 2 times the 1 oxygen that was present creates 2 oxygen for the Cl. There is also an additional oxygen present from the water. 2 plus 1 creates 3 on the product side for oxygen. Recall that the half can be easily eliminated by multiplying each of the coefficients by 2. Therefore, in front of C2H2, we place the coefficient of 2. The 1.5, when multiplied by 2, becomes 3. The 2 in front of CO, when multiplied by 2, becomes 4. And the 1, or the assumed 1 in front of H2O, simply becomes 2. We've now balanced the equation, employing the strategy by doing the oxygen atoms last.